Yeah, I live on Long Point Road.
John Brown.
I got
How's John?
The Lord be with you. Also with you. Thank you for joining us today at Grace Church. I'm the Reverend Misty Kuak, rector here at Grace. I am so excited to invite my friends, both Bill and Adrian from Williamstown. Bill is a theoretical physicist and one of the founders of the field of quantum information theory. He is professor emeritus of physics at Williams College. And this might be an urban legend, but my mentor priest in Williamstown, Nathaniel, says that Bill has been on the short list for the Nobel Prize in physics. He will deny it.
That's for the legend for sure.
So thank you for joining us today. We've got 2 seats up here. We've got some open seats on this side. We've got 3 or 4 seats on this side if you still need a chair. So while you're not too shy to come forward before he starts speaking, if you'd like to come and find a seat. Would Nancy and Paul please stand? Our summer science series continues with Nancy Kinner, our senior warden, who works with NOAA and is an environmental engineer. Am I right? It's not an urban legend. And Paul himself is a physician specializing in addiction. So please join us at the end of the month for Nancy's forum on our oceans and Paul's forum on July 13th on addiction and spirituality. Again, there are a few chairs up here. Don't be shy to come on up once you have your food. I'll hand it over to Bill.
All right, put it here. All right, can you hear me?
Yeah.
Can you hear me? Really? Okay.
No.
But this one is supposed to be nice. It's a little loud. Like that. Okay. All right.
It's not in your way.
Okay. Very good. You can hear me now. Okay.
Not
Well,
great.
Okay. All right. Okay, sorry about that. I mean, I'm a theorist, but I do know there are things like that.
Was that, it's pay.
Let's try that. Oh, good, very good. Well, okay, well, it's a pleasure to be here. Wonderful to be at your service today. To see so many people at church today, it was great. And thank you all for being here. I want to thank Misty for inviting us. And also definitely want to thank Nancy for making her cottage available to Adrian and me this weekend. So I feel very welcome. We both feel very welcome. Okay, let me begin by saying I'm not a scholar of science and religion. We have several scholars right here. I'm not that person. I'm a physicist and I'm a Christian. And that has led me to wrestle with some issues. And so that's what I'm talking about. I'll just sort of mention some issues and sort of my thoughts about them. I expect a number of you have wrestled with similar issues and may have ideas, and that would be great for those to come out in the comment and question session afterward. So I'll start with a couple of ways in which one might think that physics challenges faith, challenges religious faith, two ways. One is, think about this, in the 19th century physics, here's the picture that they had. The world consisted of particles and electric and magnetic fields, okay? And that was the whole story. If you told me the position and velocity of every particle in the universe and the configuration of the electric field and the configuration of the magnetic field, you would have told me everything. You would have given me a complete description of the universe. And also, if you gave me all that information, the laws of physics would tell you how the world would continue, how it would propagate, how it would evolve from that point forward. Okay, deterministically, like a clock. Okay, it's a clockwork universe. And what does this do with faith? Well, first of all, this reminds me of a bumper sticker that when I was in graduate school, one of my physics professors had on his office door a bumper sticker that said, "Physics is all there is." And I've joked with my colleagues at Williams about this. I told them about it. Look, man, we could save so much money by eliminating 40 departments. Physics is all there is. But that's what this picture suggests. So really, that's the whole shebang. And it also makes it a little bit tougher to think of God as an actor in the world. If the world is running like a clock, and we have this complete physical description that suggests a materialistic view and doesn't leave much room for God to act in the world. Not impossible, but it's hard to work that in. So that's one issue. The second one goes back to, say, the 1930s when it was discovered that the universe is expanding. Okay, the universe is expanding. We've seen that pretty well. In 1998, some astronomers were wondering, okay, the universe is expanding, but we expect it slowing down because everything's gravitationally pulling on everything else. And they looked to see how much it was slowing down. But in fact, what they discovered was that it's actually speeding up. The expansion is speeding up faster and faster and faster. And I saw a Netflix documentary. It's called A Trip to Infinity. Maybe you've seen it, in which they discuss this expansion, this forever accelerated expansion of the universe. And they talk about what does that mean for life. Okay, and what they say is that, well, okay, eventually our galaxy, every galaxy, so if you're a living person, living creature, your galaxy is going to run out of energy. All the stars will burn out. And because of the super fast expansion, you won't be able to get to any other galaxy because you'd have to go faster than the speed of light to get there.
No problem.
So this will happen in about 100 billion years. And so there was a cosmologist on this show, on this documentary. Her name is Janet Levin, and you see her there, and she's saying, just imagine that. There will be a last sentient being. There will be a last thought. Okay, and I think this image also challenges faith in a purposeful God. I think if this is where the universe is headed, well, how does that fit in with God having some purpose for what's going on here? And we're also reminded of a quote from the Nobel Prize winning physicist Steven Weinberg, his classic book, The First 3 Minutes. In the last paragraph or so, he says, the more the universe seems comprehensible, the more it also seems pointless. Okay. So I think this is another challenge but you should not leave the room right now. Another challenge to religion, another challenge to faith. So, and I want to emphasize, this is not just a challenge for scientists who happen to be religious. It's a science for anyone who's religious, right? Because science is with us. Okay, so for the rest of my time here, I just want to give you some of my thoughts about these matters. I have three particular thoughts. The first one is going to be the longest one, so don't worry if it's kind of goes long. The other two will be shorter, I think. The first, so I have these three thoughts. The first is about physics itself, which I feel kind of comfortable talking about because that is my field. So I think it's really significant that present day physics is very different from the 19th century physics that I was talking about. And the huge difference came 100 years ago, 1925, with the development of quantum theory. And this year, you may not know, 2025 has been declared the International Year of Quantum Science and Technology by the United Nations. Okay, that's what this year is. Celebrating 100 years of quantum theory. And that was a radical departure from 19th century physics. And it's, first of all, it's been a very successful theory. Nothing has contradicted it in those whole 100 years. Extremely successful, very practical. It has led to all sorts of great technologies. But I want to emphasize two features of quantum theory that I think are significant for us. So one is that it hardly ever makes detailed predictions about any particular event. Okay, let me take a very simple example. So a photon is a particle of light. Okay, light comes in particles, we now know. They're called photons. And suppose you have a photon coming along here and hitting a piece of glass, an ordinary piece of glass. Okay. As you know, light sometimes reflects off glass. I can see some light reflecting off glass around here. So suppose you put a photon detector right here and another one here. And you want to know, well, which of those detectors is going to click? Is it going to be this one or is it going to be this one? So quantum theory will not predict that, will not tell you the answer. It'll tell you there's a 5% chance that detector will click, a 95% chance this detector will click. But that's all it'll tell you. And once it does click, quantum theory can't tell you why that happened. Why was it this one and not that one? These events of this kind happen all over the place, everywhere, all the time. Anything you can think of that might have been different is because of some quantum events like this. Well, this chair is here and not a little inch to the left. Okay, there are some quantum events behind this, I think. So that is one thing. There's this kind of causal openness in quantum theory that was not there in 19th century physics. Okay, and the second thing is, and this is less widely known, but it's a really interesting fact, that quantum theory, as successful as it is, does not give us a complete, closed, self-contained description of the world. It's notoriously bad at that. Okay, it's a great theory, but it doesn't do what 19th century physics did, which was to allow us the possibility of imagining a complete material world. We don't have that in quantum theory. Now, many physicists don't care about that. That's fine. Look, it works. We can use it. And that's all we require of our scientific theory. We don't require a picture of the world, of the whole world. But there are other physicists and many philosophers of physics who don't like this at all and really want to find something like the 19th century view. What is the world? What is it? What's my complete description of the world? And people have tried, and I can tell you, I could talk for an hour about the attempts that people have made. It's an interesting story. They've tried in a few different ways, but basically, there are problems with all these ways that people have tried, and no school of thought has been able to convince the majority of physicists that this is the picture. If you want to talk about that some more, there's no limit to what else. It's very interesting. So that's the second thing. It does, first of all, it's not causally closed. It's got this openness, and also it has an openness in the very description of the world. I guess I could say what causes the problem. What quantum theory does is it gives you a set of possibilities. It gives you a set of possibilities, but it never explains when exactly or how one of those possibilities becomes an actual event. Okay, it never answers that question. And that's where the problem lies. Trying to answer that question is where it turns out to be very difficult. Okay, so that's my first point, that physics is different now. It's different from the way it was in the 19th century. My second point is this. I'm a big fan of the methodology of science. This business of refining hypotheses by pointing to new evidence is just a fantastic method. And it's amazing how much knowledge we have gained in this way. And those of you who are scientists know that, and I mean, everyone's aware of that, how much science has told us about the world. But something that method does not tell us is how much we don't know. Okay. And it's very easy to see the things that we do know. It's very hard to see the things that we don't know. And I like to think about, say, the ancient Greeks. They had cosmologies. Think about Aristotelian cosmology. Okay, you see, what am I doing with my hand there? That's the sphere of fixed stars. Okay, that's the sphere of stars, which circles around the Earth in a particular direction very regularly. Okay, the stars go around in circles. That cosmology fit all of the data that they had, right? They had no clue how vast their ignorance was, right? I mean, think about what the James Webb Telescope is showing us. How many billions of galaxies are out there? Okay, so it's a far cry from the sphere of fixed stars. Well, how do we know that we're closing in on the final truth, scientific truth? I mean, it's easy to think that because you see how much we know and we have the models of things. But how do we know that our island of knowledge is not immersed in a vast sea of ignorance? How can we possibly know that? We haven't gotten there yet. Okay, so there's a lot that we don't know, and we don't know how much we don't know. So that's my second point.
Sounds like philosophy is everything.
It's not like philosophy. Oh, this reminds me of a joke I saw, a cartoon I saw. I guess I'll share it. So you know are you familiar with the cartoon strip Pickles? Earl, who's the old man in Pickles, he's standing on the beach with his grandson, and he's saying to his grandson, Plato, the philosopher Plato once said, I am the wisest man, for I know one thing, and that is that I know nothing. And the grandson says, how do you know that? Earl says, His wife told him. All right, so, but we're like, because that's my second point. And my third point, my third thought about these things is that there is an aspect of existence that physics does not touch. And indeed, the whole kind of objective description method of science doesn't touch. And that is our subjective experience of the world. So our internal subjective experience. That's just not the perspective that physics uses. We always take a kind of a top-down, third-person view of here's what's going on. But we leave out the, oh, this is what it looks like. This is what it feels like. And I have some nice quotations, which I will read on that subject. So I have some in my pocket here. I have quotations from Erwin Schrödinger. So quantum theory was discovered in 1925 by Heisenberg, Born, and Jordan. But in 1926, Erwin Schrödinger came up with a completely different formulation, which turned out to be equivalent. It's called wave mechanics. So that's what he's known for among physicists. Among the general public, he's maybe better known for Schrödinger's cat. But here are some quotations from Schrödinger. He was very aware. He wrote a book called Mind and Matter, and that's what I'm quoting from, 1958. He's very aware of this limitation of science, of what it leaves out. So here he says, the physical world picture lacks all essential qualities that go to make up the subject of cognizance. The model is colorless and soundless and unpalatable. In the same way, and for the same reason, the world of science lacks or is deprived of everything that has a meaning only in relation to the consciously contemplating, perceiving, and feeling subject. Everything related to the meaning and scope of the whole display, okay, is left out of science. And here, then a few paragraphs later, he says, let me briefly mention the notorious atheism of science. Science has to suffer this reproach again and again, but unjustly so. No personal God can form part of a world model that has only become accessible at the cost of removing everything personal from it. We know when God is experienced, this is an event as real as an immediate sense perception or as one's own personality. So this is something that science does leave out, physics does leave out. And that might seem like a small thing. Oh, well, you know, eventually we'll figure that out, figure out consciousness. But that's not small at all. I mean, it's our whole world. I mean, this is where prayer happens. This is where religious experience happens. And so, I mean, this is where the prayers that Joseph quoted in his sermon today, this is where that happens, right? Christ living in me. And so physics is leaving that out altogether. So I guess I think I want to leave plenty of time for discussion. So I may end it right about now, unless you want to hear more about the different ways people have tried to come up with a complete self-contained description of the world in the face of quantum theory. But yes, there's a question.
You know, you were talking about the scientific method,
Yeah.
and there was a text, an old text by Polanyi, Personal Knowledge, that talks about that we look at data based on what we're interested in. And so the data that we looked at is biased to start with, right? So how do you incorporate that in?
Oh, right. How do we?
Yeah.
Yeah, right. Uh-huh. You're right. We do have this choice of what to look at, right? Yeah, it's a good point. And that does determine the trajectory of science. It's true. Yeah, and something could be missed or left behind because we didn't take that path.
And I'm a social scientist, I'm a psychologist, so, and there's been a lot of critique about the research method that we have used in psychology because of the cultural bias and what we look at and how we come to our conclusions based on what and leaving out all other
Right,
aspects of the world.
right.
I wonder if that, how much that impacts the science.
Yeah,
physics.
I think physics does a pretty good job of, because there are lots of physicists and they have different ideas about what's interesting. And so, and experimentalists are always looking for something new. So they'll dig around for something that hasn't been done before, let's do it. So I think physics is pretty good at sort of avoiding most of that problem. But it doesn't avoid this problem I'm talking about now, that our internal world is not part of the science. Let me just wrap up my remarks. So I guess, a lot of the problem with the challenges that science or physics might pose to religious faith come from a kind of idea that physics is all there is. But I think these points that I've made here argue, I think, pretty strongly that physics is not all there is. And so that's why it doesn't keep me. These ideas, these challenges don't keep me at all from practicing my religious faith, and from praying that Christ can live within me. So I think I'll leave it there and open it up to questions and comments, and you may have your own thoughts about some of these things. Oh, yes, there's.
I'll pass the mic. Does anyone else have a question or comment?
So, oh, yes, see, I knew people would.
Would you say something about the role of the observer in predicting the movement of protons? I find that to be
Very good. Yes, I would be happy to do that. Yeah. Because this gets at the question that I didn't talk about in the middle there, which is how does the set of possibilities become one single actuality? How do you go from all these potentials to one actual thing? And this is where physicists will disagree, and philosophers. They'll disagree with each other. For example, when the photon hits this plate, you might think the decision whether to bounce off or be transmitted happens at the encounter between the photon and the glass plate. But we can show that that's not true. That's not true. No decision is made there, because whatever happens, then we can reverse it and reconstruct the original photon. There is no decision made there. So most physicists would say, oh, well, that decision is made somehow at the detector, right here or here. But a detector is just another piece of equipment. Why should that be special? And so there is a school of thought. I have to say this is a minority among physicists, but they are there, who say, no. That achievement of something actual, as opposed to just all